Today, we're going to discuss problems on nodal analysis. So this is the circuit. You can write a circuit like this. This is the resistance. It is 5 ohm, and then this is the inductance. This is J5 ohm, and this is the one more impedance. This is 2 plus J3 ohm, and here this is resistance. It is 6 ohm, and this is your 4 ohm, and this is Vx, and then this is 30 at an angle of 0 degree. So in they can ask the question like this: use the nodal analysis to find the value of Vx in the circuit shown in the figure such that current through 2 plus J3 ohm impedance is 0. Nodal analysis is based on the Kirchhoff current law. What is the Kirchhoff current law? The algebraic sum of the currents meeting at a junction or a node is equal to 0. You have to mark the node here. You have to mark the node. This is the one node. This node is taken as a V1, and this is the another node. This node we can take it as a V2, and this is the reference node. The below one is the reference node. This is the reference node, or we can call it as a datum node. Now apply the KCL at node 1. So apply KCL at node 1. Apply KCL at node 1. So what are the branches it is connected for this node V1? So this branch is connected, and this branch is connected, and this branch is connected. So therefore, what is the current flowing through this branch? I would assume that V1 is higher potential. So therefore, we can write it as equation like this: V1 minus 30 at an angle of 0 degree divided by 5. So this V1 is current is flowing downwards, and this voltage source will be current flowing upwards. Therefore, we taken the what is the voltage means V1 minus 30 at an angle 0 divided by 5 plus what is the current flowing through this branch? It is V1 by J5 plus what is the current flowing through this branch? V1 minus V2 divided by 2 plus J3, that is equal to 0. But in this question, it said current flowing through the 2 plus J3 ohm is 0. That means this term is 0. This is the current. It is given the data current flowing through the 2 plus J3 ohm is impedance is 0. Therefore, this term will be 0. Remaining you can write it as. So take the common factor as a V1, that is 1 by 5 plus 1 by J5, that is equal to 30 at an angle of 0 degree divided by 5, that is equal to 6. Next, this is V1. Take the 1 by 5 is 0.2, 1 by is minus J, 1 by 5 is again 0.2, that is equal to 6. So calculate what is the V1 now. So from this expression, so V1 equals V1 is equal to 6 divided by 0.2 minus J 0.2, that is equal to 6 divided by point. This we convert into polar form. The polar form for this is 28 at an angle of minus 45 degree. After simplification, we get the V1 is equal to 21.216 at an angle of 45 degree volt. And he has given current flowing through the 2 plus J3 ohm impedance is 0. Therefore, E1 and V2 are equipotential because current flowing through the 2 plus J3 ohm impedance is 0 is given. Therefore, V1 and V2 are equipotential. Therefore, the V1 is equal to V2 is equal to 21.216 at an angle of 45 degree volt. Similarly, you apply the KCL at node V2 at node V2. Then we can write an expression like this. This is V2 minus V1 divided by 2 plus J3 plus V2 by 6 plus V2 minus Vx divided by 4, that is equal to 0. But he has given this current flowing through this branch is 0. Therefore, this becomes it will be 0. A remaining term you have to write. So note down another problem is based on the dependent sources. This is the diagram they give. This is the one resistor, and here there will be a current source, and here this is the connected negative and positive, and it is connected to like this. And this is the diagram. Here there will be connected one resistor like this, and this is another resistance. From here to here one more resistance you can connect here, and here there will be a different dependent voltage source. So we can write it like this, the positive negative, and it is connected to this point. So this is minus plus, and this is the Vx, and this 0.5 ohm, and this is your 2 ohm, and this is 4 amps, and this is a 12 volt, 0.5 Vx, 0.2 Vy, and this is minus plus, this is for Vy, and this resistance it is 2.5 ohm, and this is 1 ohm. Okay, and this as given as a reference node. So they can ask the question like this: find the voltages at nodes 1, 2, 3, 4 for the network shown in figure using nodal analysis. So you have to mark the node. So this is the node 1, and this is the node 2, and this is node 3, and this is the node 4. Looking from the diagram, what is the voltages? The voltage is between node and the ground point. Therefore, it is V1 is equal to minus 12 volt. Minus 12 becomes positive is connected to ground. Therefore, V1 is equal to minus 12 volt. Now apply the KCL at node 2. Apply KCL at node V2. When apply the KCL at node V2, we can write an expression like this: V2 minus V1 divided by 0.5 plus the current is entering the node, therefore that becomes, this is given as a 14 amps. This is in the exam they given the value is 14 amps. V2 minus V1 by 0.5 plus the current is entering the node, therefore it is minus 14 plus V2 minus V3 divided by 2, that is equal to 0. You simplify this. This is minus V1 by 0.5 plus V2 divided by 1 by 0.5 plus 1 by 2 minus V3 by 2 is equal to 14. Further, you can simplify this. This becomes minus 2V1 plus this is V2 into this is 2 plus 0.5 minus 0.5 V3 is equal to 14. This you take as the equation 1. Next, this is minus 2V1 plus 2.5 V2 minus 0.5 V3 is equal to 14. Call this equation as a 2. And in this case here, the voltage source is existing with the node 3 and node 4, and therefore this becomes a super loop. This is a super loop. Now apply the KCL at super node. So apply KCL at 3 4 super node. When apply the KCL at super node, we can write it as the current is entering the node, therefore this is minus 0.5 Vx plus V3 minus V2 divided by 2 plus V4 by 1 plus V4 minus V1 V4 minus V1 divided by 2.5 is equal to 0. Further, you simplify this is minus 0.5 Vx plus 0.5 V3 minus 0.5 V2 plus V4 plus, so 1 by 2.5. So how much it is? This is 1 by 2.5 V4 minus 1 by 2.5 V1 is equal to 0. Now further you simplify this. This becomes 0.5 Vx plus 0.5 V3 minus 0.5 V2 plus V4 plus 0.4 V4 0.4 V4 minus 0.4 V1 is equal to 0. Minus 0.4 V1 plus 0.5 V2 plus 0.5 V3 plus this is 1.4 V4 is equal to 0.5 Vx. But looking from the diagram, what is a Vx? Looking from the diagram, Vx is equal to V2 minus V1. Substitute this minus 0.4 V1 plus 0.5 V2 plus 0.5 V3 plus 1.4 V4 is equal to 0.5 V2 minus V1. Further you can simplify, this becomes your, this is 0.5 V1, this becomes a negative. If it comes this side, it becomes a 0.1 V1, 0.1 V1, and this is 0.5 V2, and here it is 0.5 V2, that will cancelled, then you'll get a 0.5 V3 plus 0.5 V3 plus 1.4 V4 is equal to 0. This call this equation as a 3. Next you write a constraint equation. You can write a constraint equation like this: V3 minus V4 is equal to 0.2 Vy, and V4 minus V1 is equal to Vy. To simplify this, you can take the multiplied with the 0.2. 0.2 V4 minus 0.2 V1 is equal to 0.2 Vy. So now we can V3 minus V4 is equal to 0.2 Vy, and this is 0.2 V1. 0.2 V4 minus 0.2 V1 is equal to 0.2 Vy. If you subtract, then you can write it as 0.2 V1 plus V3 minus 1.2 V4 is equal to 0. Now call this equation as a fourth. Now you can solve all the equations. Solve the equations 1, 2, 3 and 4. Then you will get a V1 is equal to minus 12 volt, and V2 is equal to minus 4 volt, V3 is equal to 0 volt, and then V4 is equal to minus 2 volt. Thank you.